Hello, welcome to this live stream presented by Swarm. My name is Joaquin Malata, and I'm your host today. With me is Dan Eaton, and Dan is the man. He's been working in the space of analytics for quite some time, more than 12 years, right?
Yep.
And you've worked with Fortune 50 companies such as Amazon, Alphabet, AT&T, United Health Group, the U.S. government, among many others. So, Dan, can you tell us a little bit about your background, where you've been, and where you are now?
Yeah, for sure. Thanks for having me, and it's just so fun to get to chat with you, Joaquin. And yeah, my background is I I'm a mechanical engineer who has just always loved technology and grew up in a household where my parents were active in technology from a very young age. Before I could talk, I can remember interacting with a personal computer that was down in my dad's home office, and I just I've always loved technology, and my my background in uh, accelerated computing really really began out of an interesting segue from the energy industry. So I was working in an innovative energy project developing a utility scale electricity generation project, and I was fortunate enough to help someone do due diligence on a investment, and the company was Seymour Cray's last company that he started, um, and the company was doing a really interesting architecture using FPGAs and CPUs to do a unified executable, creating um, a hardware accelerated embedded appliance and HPC system. And right away, I saw from my experience in the energy industry the value proposition of accelerated computing from a compute per power perspective, and what that meant in terms of being able to reduce data center capex and opex. And so that it's kind of funny because fast forward to today, and the same things are really relevant and important, and we're seeing a huge demand for accelerated compute to help with the disconnect between the demand for computing and the supply of compute infrastructure and data centers, with North American data centers having just a a sliver of excess capacity. We've gotten to a place where it's really really important for companies to look at how to take hardware acceleration and get more computing done with the same amount of physical space and electricity. So it's really really cool cool time to be in this space, and yeah, just look forward to having a just a fun conversation.
Um, this is news to me that you have a mechanical engineering background, and I feel like a terrible host for not knowing that before our first interview, but that tells me a lot. There seems to be this meme on personality types for different engineers, but mechanical engineers seem to be the most lively, gregarious type. So it's all coming together. It all makes sense now.
I fit the stereotype.
Yes, I'm stereotyping you hard with the mechanical engineering.
That's funny. You'll have to forward me some of the top samples of that meme. I've always enjoyed systems and how things fit together and work. My wife jokes about sometimes I'll I'll spend too much time asking the why and the why and the how and the why, and it's like eventually talking with engineers can be like wrestling with pigs in the mud. It's a big perspective change when you realize that they like it. They actually like getting into these details and really understanding what the underlying drivers are behind all these systems in our lives. So yeah, it's funny. It's funny how we're all wired a little bit differently.
I especially like the fact that mechanical engineering, and I won't stay too deep into this area, but mechanical engineering is such a broad but helpful primer across all other engineering disciplines. And for me, it fascinates me that you went from mechanical engineering, power production, accelerated computing, sales of those engagements, and then being more on the business side, and trying to empathize with engineers reaching these limitations in their daily workflows, and them trying to accomplish something, to you having that empathy and helping them as a guide, as a consultant, as a salesperson. How can I enable these other folks trying to solve problems to do the
For
thing that they want?
for sure. And it's one of those things where really I what draws me to uh, hardware acceleration and analytics is the fact that some of the largest challenges uh, of our decade are getting addressed by applying these technologies, and really um, where I really get excited is kind of at the state of the art and at the innovation frontier, where people are applying new technologies, and sometimes it can be exponentially different. Sometimes it can be just incremental evolutions of existing technologies. But it's just really fun to do, and I love the opportunity to work with technologists, whether they're IT infrastructure folks or whether it's data engineers and data scientists. I love just helping people apply technology to solve their business and organization objectives, and so it's just a really fun thing to do. So I'm really happy to be where I am today, and yeah, I'd love to jump in and talk about some of these incredible macro trends and technologies.
Well, before we jump into that, tell me what's hot with speed data. Tell me why you're there. You're
Yeah,
saying, "Oh,
for
I,
sure.
I like hanging out with the cool kids. I like doing what's new and hip and all this stuff." But what's hip with speed data, and why are
Yeah,
they? Why are you
yeah.
there?
I think you're asking a question that's actually going to get a funny response. We um, I think that the cool kids today are probably doing something with LLMs. I think the the business that we're in at Speed Data is more like being a plumber. So it's not quite as cool, not quite as trendy, but you need to have the data flowing into these systems, and you need to be able to do your feature extraction and your advanced analytics to support all these LLM systems and compound AI systems that go beyond just monolithic models or even mixture of expert models. So we're in a really fun spot where data analytics is actually the biggest data center workload today. And so we built a chip specifically for that workload, and it's the first in the world where we designed an ASIC from scratch solely for analytical database workloads. we can't really help you if you need video encoding or training neural networks or any other workload. We're very, very focused on that. But the beautiful thing is we can help customers that have large scale analytical database workloads. We first integrated with Apache Spark because of Apache Spark's broad adoption and the fact that it's open source. So we were able to make some really great seamless integrations with the mature ecosystem that Spark has. So today, customers can take their legacy Apache Spark workloads and transparently accelerate them. And what we're seeing right now is about a 50x better performance per dollar compared to CPUs and GPUs. And it sounds like marketing nonsense because it's such a substantial acceleration. But how I kind of look at it and talk about it is it's the same way that if you run Bitcoin mining on a CPU or a GPU, when you move to an ASIC, you get orders of magnitude better performance because that ASIC was designed solely for that particular use case, and running that hashing algorithm on the ASIC is the ultimate in efficiency and performance. So that's kind of the analogy that I use, and it's something that is really a lot of fun, and I'm so excited to keep working with these incredible customers and partners to take our technology and then help them breathe new life into their legacy big data deployments. And we're super focused on Spark today. We're beginning to work with a few customers and strategic independent software vendors to say what do we integrate with next to provide zero code change acceleration. And yeah, that's where we're at. We're also in our product development lifecycle. We're really excited because we're going to have our first production chips available this year, which is if you've ever been a part of a hardware startup, having your first production silicon and being able to deliver those systems and install them is really, really exciting. So it's a fun time. I think there's nothing like taping out and bringing up and then validating and installing your first systems.
I think you might say it's not cool to do plumbing, but you can't have a party without running water. You can't throw a pool party or flush the bathroom if there's no plumbing or water in place. So you're doing a very valuable service. Yeah, so Speed Data is creating these custom processors that are fit for a specific use. It makes sense. If you have something that has a general function, it's the trade-off is that it's not going to have a specific function, and vice versa. Um, where you said you wanted to go into some of the macro trends. I think one of the things that we wanted to discuss is now LLMs and the massive consumption of power, the massive consumption of computing power that it's required. But I think this is in line with that topic that current data centers, current cloud computing data centers that run these LLMs rely on general processing power, things that are not fit for use for this specific kind of function. And the life cycle or change cycle of producing a new chipset, getting it manufactured, and then putting it into production to replace existing infrastructure is a big investment of time and energy and capital, right? And a lot of moving logistical pieces to boot. So
For sure. Yeah, this day and age, you will need 50 to 100 people working for 4 to 5 years and around $100 million to bring your first ASIC to market.
That's it.
And yeah, exactly. So I think SoftBank announced that they're looking to create raise $100 billion to create a competitor to NVIDIA. That's much larger scale than what we're talking about, but it's very, very capital and time intensive, and that's why you don't see as many startups in the hardware semiconductor processor accelerator space. Though
It's
there is a little bit of a renaissance that's been happening over the last 5 years with a number of companies in the AI training and AI inferencing space, but it's a very capital intensive thing, and it's been really fun in the last week to see some of those startups make some noise. I think most notably Grok, GROQ, not GROK, not to be confused with X's Grok, but GROQ is showing a really, really cool demo of inferencing at a speed that you're interacting with the technology, and you're inserting a prompt and you're seeing text generated at a rate that is unbelievable, absolutely unbelievable.
So there are innovations in the hardware space. It's pay to play, unfortunately. There's few players involved, and there's long lead cycles. The production of new large language models and generative AI is improving. Research and development is improving. I think everybody's just got their eyeballs glued to their computer screens to see what's going to happen. But the focus of everybody is how do we make better models? How do we make them larger? Now some developments are how do we make them small and energy efficient, computing efficient. But the point is that we're going into the secondary information industrial revolution, right? And when I say information, I mean IT, information technology industrial revolution, to be more specific. Maybe we can consider the internet being the first, but this is the second. Just with the explosion of consuming and using language as an interface. But yeah, we're right now as it stands, we're ill equipped to deal with the consumption use. People are using it to get recipes. People are using it to read their horoscope. People are using it to do a bunch of silly things. But we should be using this capital and energy expenditures on scientific or some sort of really novel, useful, economical application, right?
For sure, for sure. And I think we're going to see uh, both the functionality and the accuracy of these systems kind of dictate the next wave of evolution. And uh, Bear at Berkeley released a really interesting blog post a few days ago about the shift from models and kind of using a monolithic model to compound AI systems, and thinking about how do you make things more efficient. The joke I use is, if you can use Excel, use Excel, and that's something that we definitely are seeing organizations as they adopt LLMs realizing maybe I don't need a trillion parameter model to do something that a 7 billion parameter model can do, or even something that maybe is a smart way of caching or knowledge knowledge retrieval or business rules or some type of traditional machine learning technique that helps more efficiently support inferencing. I think there's a ton of stuff that we're going to see that it starts with accuracy and precision. And so if your systems aren't being accurate, you're gonna see an evolution, and people are going to augment the capabilities of some of these large language models. And I think that's driven on the use case side. And then I see there's also just a tremendous amount of incredible research that's ongoing, and this is what I think is in the public domain, and everyone knows about. It's like every week it feels like Christmas, where someone drops a new model, and there's a new paper, and I think we're going to see some really novel things come out that cause for everything from new math approaches to just using things that have already kind of been used outside of language models, things like pruning and quantization, which it's like there's lots and lots of ways for us to get more efficient. Also, where do we deploy these models for inference? I think there's some really exciting stuff that people are doing with deploying smaller models for inference out on the devices, on mobile devices, on laptops. I think AMD most notably is using some I think they called them AI engines a few years ago. They might have a better branding name for them now, but they're actually including those in their x86. So it's like you're seeing specialized hardware show up even in a laptop computer that's going to make deploying some of these models for inference very, very fast. And other cool startups doing things like pruning and quantization, like Neural Magic, are taking approaches to figure out how do you shrink things down, how do you make them more efficient, and it's a really cool space to be in. And I think all that being said, there's still for especially the largest models, there's a tremendous amount of compute necessary for those. And NVIDIA's earnings that happened just yesterday show that. I mean, you can literally plot on the quarterly earnings releases for NVIDIA when large language models started, and you can just draw an incredible trend, a trend that looks like Cisco during the .com era. And I think that's going to continue for many quarters, whether it's 3 quarters or 10 quarters, I don't know, but there's going to be a tremendous amount of compute applied to training these large parameter models, and then also even deploying them for inference, because they're so big that they actually take a lot of compute resources for deploying the models for inference.
I think these are all just speculations. This is not investment advice, guys. Anybody that's listening in, just asterisks here.
For sure. We're just two guys talking about what we see out there, and I think it's something too that there's a lot of experts in this space that are more well informed than we are, but I think it's an exciting time to be in this space, because these types of things really, you only see them kind of once every 10 years. There's something as substantial as this. I mean, if we go back and look at NVIDIA, they've had a fantastic 30-year run and many cycles. Something as big as crypto and blockchain, something as big as that looks tiny on the chart compared to what we're experiencing right now.
I think you're bringing up the the question of this time, right? The question of this time: who's going to bear the burden of computing, of processing, of transforming a question into an answer across devices? Is it the cloud infrastructure data centers? Is it that we're going to bring it back into proprietary data centers? Are we going to buy custom machines and install them on premise and have employees maybe remote log in to do their processing? It's unclear. No, you're saying there's a lot of scholarly intellectuals that are out there that are doing the hard thinking around what is coming up next, but I personally think nobody knows. Nobody knows what's going to happen, right? I mean, we all can speculate, like with the internet. Some people were naysayers, some people were yay sayers, but at the end of the day, um, you know,
For
it,
sure.
it
For
drastically
sure.
changed.
No one knows, but I do think right now what we're seeing across the kind of biggest enterprise customers and public sector, um, we're going to what we're seeing right now is the adoption of large language models primarily as chatbots. That's kind of the first application that we're seeing, and it makes perfect sense for how well LLMs can number one interact with people. They're just a great API, and then number two, their ability to do things like qualitative understanding of unstructured text. It's like that's something that for the longest time, if you've been in the kind of enterprise, search is horrible. Enterprise search is like it's usually a joke where like someone will say I can't find anything using the search functionality on my intranet, and it's like that's common across the board. Um, but where the LLMs are needing these kind of compound systems, the first thing that people look at is RAG and adding in like you chunk up your unstructured text, and you can speed up the rate that your chatbot's kind of able to answer questions and do semantic search. And that's people are seeing value in that and incremental improvements over legacy technology. But the part where we're really seeing folks struggle, and there was a great paper a little over a quarter ago that came out that said LLMs are horrible at answering advanced analytical questions in the enterprise. If you ask the LLM how many widgets did we sell last quarter in a particular region, it gets it wrong the vast majority of the time. The paper that I can share in the comments was saying for most advanced analytical questions, accuracy is zero. It literally just can't do it, and the reason why is because the LLM's really good at predicting the next word in a sentence, but with that question, you actually need to have a structured stone tablet of quantitatively what is the right answer, and having a data warehouse or a big data tool where you've got that structured understanding of your enterprise knowledge is something that's absolutely critical. So we're just starting to see people now attaching LLMs and integrating LLMs with their enterprise data warehouse or enterprise knowledge graph, and that's something that is it is very clear that that's happening right now, and I think it's an incremental integration of technologies. I don't think there's any eurekas that need to happen, So that's really exciting, and I think beyond that, I totally agree with you. There's going to be some incredible things that come up, and we can't possibly anticipate those. Um, like during the .com boom, a company that sold books online, inventing cloud computing, and there's things that we can't even anticipate. So it's a fun time to be around.
Yeah, I wanted to jump on that thing that you're saying with the LLMs. I mean, LLMs are large language models. So they're models which are representations of something based on how many things they're fit in, right? Large language, meaning that there's a lot of words or ideas or parameters. Um, these models, as you were saying, are just anticipating statistically what is likely the most relevant source of information to perform. I think this kind of thinking of statistics is the way to resolve everything is part of the aftermath of oh, let's data is the new oil, so let's do big data and let's invest in big data. But this is all nonsense because data without the modeling of what it means or what it's supposed to represent in terms of the real world, how it reflects and paints a picture, I think that's severely lacking. Even though we're making all these advancements with the algorithms, these open source models, um, not just large language models, but image models, sound models, all these generative AI permutations. You also mentioned knowledge graphs, and that kind of technology that's been around since before the 70s. That's mainly lived in academia that is seeing adoption now in the enterprise. That is, I think that is the way forward, where we have symbolic representation. We have human knowledge kind of drawn in a schematic, in a blueprint that represents how we reason with the world, how we reason with actors, how we reason with actions and events, and we make it interoperable. So when we plug in the big data, now we're feeding it into something that has shape. Now we're feeding it into something that we can reason like, okay, if John buys a cup of coffee, we got revenue, we got to buy more beans, we got to do more things. I mean, that's where we can get the fact-based answers we're looking for. That's when we can get the proper search functionality.
For sure, for sure. And this concept that you said, like the shape of data needs to be preserved, and there needs to be a model that represents how reality is actually interconnected and the relationships inside of that. And that's something that I think uh, digital twins um, and knowledge graphs are going to be really, really helpful to be able to give that context of how things are interconnected, so that when you ask those questions, you're really able to ask more complicated questions where there's more hierarchies and interconnections and business logic. So I totally agree. I think Andrew Ng he talked about data being food for AI, and it was kind of like taking the approach of, you don't want to just throw massive amounts um, of, of 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 just random calories at people. You want to have just just like
Thoughtful.
healthy and like necessary amounts of food. So it's like, I think from a data perspective, understanding the true shape of that data and building real world models of how the data is interconnected, and preserving that shape of that data as you're feeding it into any type of machine learning system, not just deep learning. But I think that's going to be very, very important, and it's also something that I'm seeing at customers too, where customers are building these compound AI systems. Just kind of a fancy word for saying build a architecture based on all the necessary components to answer your business objective. And I think it's fun because there's nothing really new under the sun. And in the same way that back propagation for training convolutional neural networks that's not new. In the same way, some of these compound AI systems are using legacy approaches and technologies that are a good fit for the particular domain that you're in. And that's something that I think is it's great. It's going to deliver on the promise of AI when you expand beyond transformers and these massive monolithic models. And yeah, it's awesome.
It's such a complex environment because, as you're saying, there is what already exists today, what people are adopting, and sort of these proof of concepts or pilots in the research laboratories, in people's laptops. People are downloading open source models to play around with this stuff. Nobody has any straightforward answers because what you do in a trivial environment may not be fit for use in a production environment. But I think that that idea that you just illustrated, data is food for AI. So the AI needs to have a sense of purpose. It needs to be solving a very specific use case or problem, and then it needs a very specific food for that. I think LLMs, as they're being used right now, it's greedy. It's a gluttonous, consumption of energy of data, but it may not necessarily be producing the lean and mean approach that we need to produce for us to do this at scale. You know, one person asking a question might consume some power, but if you like scale that to everybody in America, 300 million people, asking what's the weather going to be like today when they could just look at the weather channel, you know,
Yes.
there's energy efficient ways of
Yeah.
getting
Yeah,
information.
for sure. And I think the compound AI systems that we're going to start seeing, especially where the compute cost is supported by an enterprise budget. What you're going to start seeing is people saying, how do we make this more efficient when we scale it? Because like you said, if you and I have a Chat GPT plus subscription and we're asking more questions, then we'll pay the bill for the GPUs running inference in Azure, and that's something that we don't feel that cost, but enterprises that are deploying these systems, they feel that cost very, very quickly. And it's something that I actually really think the inefficiency of a very, very large transformer model for prototyping things is actually okay. I think
Yeah,
it's totally fine, and I think for builders that are prototyping things and just trying to get to a functional app, it's like in technology we do that all the time. Where if there's something that's fast and gets us to functionality really, really quickly, that's great. And then as you're trying to scale, that's when you want to look at those performance optimizations and start saying, okay, we did it first, maybe with a technology that helped us go really, really fast. And now we have to say, how do we make it performant? How do we make it cost effective? And that's where I think the enterprises are probably going to lead that, because Chat GPT for GPT plus users, we don't really feel the cost of it right now, because we're really paying for it, not with our monthly subscription, but also with all of our prompts. Our prompts are golden data, so we're actually giving OpenAI just a tremendous amount of very, very valuable data that's going to help them both improve their products, but also pull away from alternative technologies. So yeah, we don't really feel it in our pockets, but enterprises do, and so that's where I think enterprises are going to be pushing that. How do we make it more efficient? Is it going from a 70 billion parameter model to a 7? Is it having a vector database or a graph or a rules engine or some other compound AI component support those queries, like the Weather Channel API? I'm gonna start using that one, Joaquin.
Come on, bro. I mean,
Come on.
it's not an API call. It's just on the
Yeah,
it's on the
yeah.
TV, you know?
Yeah, it's there's all sorts of funny things that I've even found myself putting into a prompt where it's like I should just use an enterprise grade uh, search engine, or just some type of expert system to get an answer, versus asking the LLM and chatbot to answer it for me. And it's great. And I think that enterprises will lead that incremental performance optimization and improvements.
I don't want to be ruffling the feathers of the LLM fanboys, you know, or fangirls. I don't want to be the negative Nancy in the back of the room saying, yeah, you know, but it's greedy. I just want to say that I see that I will take ownership of what I'm going to say. People are lazy. They like what is easiest to engage with, and LLMs makes it really easy to engage with information that is digestible in a format that enables you to take action. Now, it's not based on all 100% facts. It's based on statistically this sounds about right. It's someone who can speak really well, that can bullshit you really well, but it sounds right, so you're gonna try it anyways. So it's like just having a semi dubious friend giving you advice. But there are energy efficient ways of accomplishing that, and we're walking away from reading long blogs, watching long videos, truly understanding what it is that we want to accomplish, to immediate gratification of accessing these interfaces, right? Because these are, as you said, the preliminary component to a usable chatbot in the enterprise. But there's other ways to accomplish that are efficient, that exist, that we just haven't explored because it's harder, because it requires a little bit more thinking and a little bit more work, you know?
Mhm.
So I just want to, put it out there. I am really excited. I really am excited that graph specific hardware has been in development. I am excited that processing power is getting better. I want to play better video games. I want to watch better videos. I want to be involved in scientific labs, to democratize science. So I don't have to work in a chemical laboratory, but I can grab some test tubes and vials, and it kind of simulates real world physics. That's really interesting.
Mhm.
I'm just
For
wor-
sure. 100%. And I love your comment on LLMs. And I think Sam Altman said that he sees superhuman levels of persuasion before superhuman levels of intelligence. And I do think that makes sense based on what the Transformers are, where it's like they're going to have such a good handle on predicting things that are coming next. And with that corpus of all this written language, I think being able to project something that is compelling is it's in order. And I already see it right now, where it's like when you interact with some of the larger scale models, whether it's GPT-4 or some of the other ones, I mean, it's amazing how compelling it is.
It,
And
I've just seen this change of even though it's I just I was born in '94. I'm gonna date myself, give a little personal information that's bad, but whatever. I remember
last century, yeah, you're bringing me back.
I remember seeing my aunts with curly hair, and I remember just people dialing into the phones, the rotary phones, to make phone calls. But people looked into books and they reasoned with things, and they said, "Hey, what you're saying doesn't that sounds like bullshit. That doesn't make any sense, or that sounds about right." But when Google came in, that became a verb. Google that, and now we're gonna have, or we have now, ChatGPT that. So where is the facility of information and decision making going? That's the only concern I'm bringing up. Graph hardware, all those improvements are the bomb.com. That's really cool. For scientific applications, like we have really advanced sensors that are capable of like measuring humidity, measuring temperature, measuring oxygen levels in the in the ocean. And we need to compute that to get accurate readings and do scientific applications. If we want to do drug discovery, we have to create these molecules, diagrams, and figure out how they fit into proteins and figure out how to like improve the rapid prototyping development of what drugs can be made, which drugs will be complementary to proteins to be effective for disease that we have, and how we can manufacture them. That's super cool, right? That should help society. um
For sure. And your reminder of it's good to read books, and it's good to consume information, and then process it and arrive at your own conclusions and applications. In 2011, Harvard wrote a really interesting piece on how Google is almost like a extension of our memory. So when students know that something exists in Google, they are less likely to retain it in their own brain. And I think about that too, where my wife is my extended cache of many topics, ranging from people's birthdays to all sorts of advanced higher level EQ
Sounds
concepts.
GPT.
Yeah, totally. And I think it's just good to be conscious of it. But I'm also excited because what I see is uh, companies that are taking more advanced things that are harder to access for the general population, where there's learning curves and there's barriers to use things. Like in particular, there's my focus is on analytics, and we're starting to see Databricks gave a great presentation with Microsoft where they showed how you can use essentially the LLM enabled query to search and form your SQL, but also to do metadata extraction to start getting context in some of the less structured or unstructured portions of your data to like create kind of like curated metadata. But the LLM is the one that's doing that. That's saying, based on what I'm seeing in this metadata, it looks like it's this particular it's this particular kind of data set, and I think that's breaking down those barriers is going to be it's going to unlock human kind of capability I do think it's definitely, and I can see how there's various perspectives on causing human retention to decrease, and some of our kind of there's some negative impacts too that subsequent to 2011, when that kind of transactive memory extension. If you know something on Google, you won't retain it as frequently in your own brain. I think there's some other adverse impacts of screens, and I won't even pull
Yeah,
us into that. I won't even pull us into that dimension. But I do think it's also worth talking about the reduction in some of these barriers to
yes.
ask questions and do things
I
that were impossible before. And I think it's just it's a really fun time to be around this space, because um, as as you have a natural language API with LLMs to reach into some of these harder to reach places that there was a learning curve or a technology barrier. I think that's where I'm really excited, and I think there's some super cool stuff out there.
I'm gonna switch teams for a second, and I'm gonna join the team pro LLMs and all this stuff right now. But two things I'm really excited about, if we take away power consumption and hardware limitations for the time being, because you guys are working on that and other people are working on that. Education, like democratization of education, you can have a private tutor, and if you have a large data set and domain specific data set like Khan Academy,
Mhm.
they instituted private tutors. You know, you can already go to Khan Academy and watch modularized lessons and get feedback, but now you can ask infinite questions,
Yes.
not in the span of 1 hour for a private tutor, but
Yep.
it can give you like reasonable explanations, context specific explanations. Why do I do the quadratic formula like this?
Mhm.
How do I do my multiplication tables like that? How do I do differential equations like this? That's really cool. That helps out people from underprivileged backgrounds. You know, I'm really behind that. And then the second one is, you said it's a language API, application programming interface. It's an interface of natural language.
Mhm.
And one really cool thing is, I would love to talk to King. Man, what's his name? Uh, I would love to talk to mummies. I would love to talk to Abraham Lincoln. I would love to talk to cultural reservoirs,
Yeah.
be that museums, be that
Yes.
libraries. I would love
Yes.
to talk to Mark Twain. That's really cool, you know, and I think that holds again to the area of education,
Mhm.
being able to revive dead languages,
Mhm.
being able to interface museums around, just curiosities and lessons and more immersive experiences. I think that's going to bring a richness to our world. We don't necessarily need to go into the realm of virtual reality yet, but augmented reality and just providing a door or interface to all the reservoirs of knowledge that we've collected over hundreds of or thousands of years, right?
Mhm.
Um, you could take Phoenician, Egyptian hieroglyphics, do computer vision to translate that into symbols, assign values to those symbols, convert those values into words, convert those words into English, and you could reason, oh, some guy is complaining that the clay tablets that they bought from this other dude were duds. You know, I'm not gonna buy clay tablets from that guy 2,000 years ago. Uh, that's just, to me, what's interesting.
For sure. For sure. I totally think that that's something that will be a net benefit and help us, because um, that being able to interact with um, some of these knowledge bases um, and writings, and kind of like um, w- you dated yourself. I won't date myself. I'm going to stay timeless, but the the thing that's incredible about the internet and search engines is really we're living in an interconnected Library of Alexandria type age where information has never been more accessible, and LLMs and natural language interfaces are going to kind of reduce that further. And it's just fun to be a part of, for sure.
Who should reach out to you for what purposes, and how can you help them?
Yeah, for sure. Yeah, anybody who has a Spark a Spark cluster that's running analytics workloads, whether it's open source Spark or from an independent software vendor. We've got a PCIe card that'll be available this year that goes in and just transparently accelerates your analytics workloads on Spark. So and the cost savings is substantial. Time to insight savings is substantial. How we can work together is today we've got a workload analyzer where you can take Spark logs from your Spark workloads, drop them into our browser-based tool, and we'll actually show you the specific parts of your queries that are accelerated by our chip, what parts of the query remain on the host CPU, and we can show you quantitatively what the time to insight improvements are, and then the infrastructure cost savings. And when you kind of add that all up and look at it, we're seeing like a 50 times better performance per dollar relative to CPUs and GPUs.
Without name dropping, can you just talk a little bit about the industries and use cases that you're seeing now?
For sure. Yeah, Apache Spark for analytics is pretty ubiquitous across industries. So financial services, retail, healthcare, life sciences, telecommunications, oil and gas, public sector. It's pretty ubiquitously used. I think the kind of rule of thumb for people is if you have queries that are running anything beyond minutes, it's going to be really ripe for acceleration. And that's kind of based on our architecture. We optimized it based on large scale analytics. So kind of like total throughput. If it's a shorter query or something that's more transactional in nature, it's not a good fit for our technology. You want to keep those on CPUs.
Okay, so like things that are accruing massive amounts of data over short periods of time, and they're just continuously streaming and aggregating. So there's like some sort of exponential nature that needs to be processed, right? Not
Yeah, for sure. The way kind of data pipelines for the most part are set up is you've got like capturing the data, pulling it in off devices and other systems. Then you kind of ingest that data and store it. Where we come in is the analytical processing of the data. So you've got your data in a structured format, and you want to understand some trends. You want to kind of apply a bunch of SQL functions to look for how many widgets did you sell last quarter in this particular region within this window of time, and you want to apply SQL to understand, do that needle in a haystack or trend analysis, or you want to extract some features for your models. So for personalization, recommendation, fraud detection, you can use Apache Spark to extract those features, and some of those are pretty analytically intensive features. So that's kind of our sweet spot, but we can help people qualify really quickly if it's a good fit, and what's not a good fit.
And even if it's whether it is or whether it isn't a good fit, I'm sure you can point them in the right direction for their specific use
For
case
sure, for
if need.
sure. Yeah, I love talking to anybody. We can always benefit from taking 5 minutes to chatting with someone, and yeah, I think there's a tremendous amount of opportunities out there for performance optimization and acceleration.
Well, I think we're at the 1 hour mark. So thank you guys for joining us on our uh, heated debate as to the pros and cons of these things. But hardware at the end of the day, whether we're being greedy with algorithms or not, it's going to pave the way for us to have advanced applications that are, you know, more more capital efficient than what you would otherwise be able to gain from cloud infrastructure. So yeah, reach out.
Awesome, awesome. Thanks, Joaquin, and thanks everyone.